Hello, you are welcome to this video, or should I say the lesson for today. Alright, so what we are going to look at today is actually balancing of equations. Okay, so converting a word equation into a chemical equation and also balancing the equation, the chemical equation. Alright, so that is what we are actually going to look at today, and it is very simple. Make sure that you understand this full video, watch it in full. Okay, so don't say I know how to do this, I know how to do that. There are some concepts that I'm going to explain, you don't need to miss them. All right, so let's start. So we need to know first what is a word equation. Okay, so this is an equation that is which we have been given, and it is actually a word equation. A word equation, it is a representation of reactions, okay, of a reaction in a word form. Okay, so this is a reaction of hydrogen and oxygen to give what? To give water. Now it is in word, that is why it is called a word equation. So a word equation always will be in words. Okay, so now what we are going to write is a chemical equation. Okay, we are going to write a chemical equation of this and balance that chemical equation. All right, so you know these are state symbols, you need to be careful with them. Okay, you need to be careful with them, follow them the way they are, just like that. All right, so you know, we are going to write a chemical equation. Now we need to know what a chemical equation is. So a chemical equation is actually an equation that represents the reactions. Okay, now it is represented in symbols. Okay, so like the symbol for hydrogen, it is what? It is H, capital H, like that. The symbol for oxygen, it is capital O, like that. So it is going to be represented by these symbols, not words. Okay, so now how do you write these? How do you write an equation of this? So we have hydrogen, so we have hydrogen, so we are going to put hydrogen, but what you need to know is that these are diatomic molecules. Hydrogen and oxygen, they are diatomic molecules, meaning that they exist like this, not as oxygen as a single atom. No, so they exist as two atoms. So oxygen, you write it like this. So oxygen, it is in gaseous state, then it's saying that plus, okay, plus the oxygen, it is a diatomic molecule, it exists like that. Okay, so this is the oxygen, then this is equal to water. What is water? Water, how do you write water? So you write water as H2O, and it is actually in liquid form. Oxygen, it is a gas. Okay, so like that. So that is how you write the chemical equation. So this is a word equation, this is a chemical equation. Now how do you balance the equation? How do you balance the equation? So now what do we do? Okay, so what do you do? You count the, you know, balancing the equation, meaning that if there is an equal sign here, okay, if there is an equal sign, if this side there is 2, also this side must be what? Must be 2. If there is 3, also this side must be what? Must be 3. This, it is the equal sign, meaning that it is equal. All right, so what we are going to do is very simple. We are going to count the number of atoms this side. They must be equal to the number of atoms this side. Okay, so you start them step by step. Okay, step by step. Make sure that if it is hydrogen, you just go for hydrogen, you compare with the hydrogen the other side. Okay, so if let's start solving. So this is hydrogen and we have 2 atoms of hydrogen. How about this side? This side we have what? We have 2 atoms of hydrogen, meaning that hydrogen is balanced 2 and 2. How about oxygen? Oxygen on the left side we have 2. Oxygen on the right side we have 1. Okay, so we have 2. This side we have what? We have 1. So what do you do for you to have 2 this side, 2 atoms of oxygen this side? So what you're supposed to do is to introduce the 2. You need to multiply this by what? By 2. Now this, it is just like this. It's simply implying that we have 2 multiplied by H2 like that, H2O like that. That is what it is implying, meaning that we have 2 times 2, meaning that we have how many hydrogens? We have 4. 2 times 2, it is 4. Then 2 times 1 here, meaning that there is 1 here. Okay, there is 1 oxygen. So 2 times 2 mean that we have all 2 like that. That is what it is implying here. So meaning that we have 2 atoms of what? 2 atoms of oxygen and 4 atoms of what? Of hydrogen. So what do you do this side? You introduce again a 2 this side, because hydrogen this side there is 4. Even this side must be 4. Okay, so 2 times 2, that's 4. So meaning that this equation has been balanced. So that is how you balance that kind of an equation. Okay, so let's look at the second equation that we have. So we have this equation: magnesium plus oxygen gas. Magnesium solid, magnesium is a metal. Okay, magnesium is a metal. Yes, so oxygen, it's a gas. So when magnesium reacts with what? With oxygen, the product is magnesium oxide. Okay, the product is going to be magnesium oxide as a solid. All right, so now this is what you're going to do. Magnesium, the symbol for magnesium, it is just Mg like that. Okay, it is Mg. You should check on the periodic table, it's there. Then the plus, okay, plus the oxygen. Oxygen exists like this. This is a solid like that, right? Then we move forward. We say is equal to magnesium oxide. Magnesium what? Magnesium oxide. If you look at what we did in the previous videos about making a chemical formula, magnesium oxide, it is a combination, it is actually a compound that is made from what? That is made from magnesium and oxygen. So what we are doing, we are saying that we have magnesium. Okay, magnesium, then we have what? We have oxygen. All right, so that oxygen on the periodic table, it has the valence of 2. Magnesium on the periodic table has a valence of what? Has a valence of 2. Okay, so you do this. That is what we said. This comes this side and the 2 comes that side. So mean that when you divide by 2 as a common factor, you have magnesium 1 and oxygen what? 1. Meaning that the equation, the chemical formula will be magnesium oxide. Okay, because this is 1, this is 1, this is 1, right? So meaning that, so now here you just have to be imagining. Now you need to imagine what you are supposed to do to make a chemical formula. So that oxygen has a valence of 2 and magnesium has a valence 2. When they exchange valences, they will divide with the common factor, which is 1, which means that they are going to be 1. So meaning that we are going to have magnesium oxide like that, but it is what? A solid. Okay, it is a solid. So that is how you do it. Okay, so that is how you are supposed to do it. Now, is this equation balanced? Okay, so let's check if this equation is balanced. So if we look at here, we have magnesium 1 atom of magnesium, and this side we have 1 atom of magnesium. This side we have how many? We have 2 atoms of oxygen. This side we have 1 atom of oxygen. So what do? You put a 2, you multiply this by 2, meaning that you have 2 atoms of magnesium and 2 atoms of oxygen. So meaning that oxygen is balanced 2, 2, but magnesium has been affected. Okay, so what you need is now, this is a 2. Okay, so meaning that we're supposed to put a 2 as well this side, so that we might have 2 atoms of magnesium, 2 atoms of magnesium this side. So this equation is balanced because we have 2 magnesium, 2 magnesium, we have 2 oxygen and 2 oxygen, like that. So this equation is also balanced. Okay, we go to the next one. The next one is saying that we have sodium. Okay, sodium, you know that sodium, the symbol is like this, sodium, like that. Okay, then the plus water. How do you write water? Like this, H2O, like that. Okay, you know that water is in liquid state, sodium is a metal solid state, like that. So it is equal to sodium hydroxide, sodium hydroxide. So you know that sodium hydroxide, it will be like this. So we said that sodium, in the previous video we said that sodium has a valence of 1. Okay, then this is hydroxide as a valence of what? Of 1. So you just imagine when they swap valences, meaning that they're just going to be sodium hydroxide, like that. Okay, because they are 1 1, just like that. So do this. So sodium hydroxide, like that. So you don't need to show all this. Okay, you need to just imagine or just solve it from your head. Okay, solve it from your head, then you write the answer here. Okay, so sodium hydroxide plus what? Hydrogen gas. So sodium hydroxide, it is in aqueous state. Okay, in aqueous state, let me write it like this, aqueous, AQ. Okay, then plus what? Plus hydrogen gas. So hydrogen, you know that hydrogen exists as a diatomic molecule, like that, and it is a gas. Okay, what you're supposed to do next, it is just to balance. Sodium we have 1, sodium we have 1. Okay, so let's go to hydrogen. Hydrogen we have 2, hydrogen we have 2. It's balanced. Oxygen, hydrogen we have 2 here. Here we have how many? We have 2 plus what? Plus 1. We have hydrogen here. So meaning that we have 3 here. Okay, meaning that we have 3. So what are we going to do? So what we are going to do is that we need to multiply this. We need to look for what we can do for us to have equal hydrogen this side and the other side. So what we are going to do is that since we have 2 here, we have 2 hydrogens, right? And this, and here we have 1. So we can make them 4 because we know that we need, when we add 2 here, there will be 4. So what we should do is you add the 2 here, okay? Meaning that you are going to have 2 sodium, 2 oxygen, then 2 hydrogen, like that, right? 2 hydrogen, okay? So meaning that we have 2 hydrogens here and 2 hydrogens there, meaning that we have 4 hydrogens. So how are we going to have 4 hydrogen this side? So we are going to put a 2 if we want to have 4 hydrogens here. So meaning that we have 2 times 2, that's 4. Even here we have 2 plus 2, 4. But the oxygen here has got how many? 2 times oxygen, we have 2. How about this side? 2 times oxygen, we have 2, like that. Okay, so you go again to sodium. Let's look at sodium. Sodium here has been affected, it's 2. We come here, we just put 2, meaning that the equation is balanced. We have 2 sodium, 2 sodium, 4 oxygen, we have 2 plus 2, that is 4. 4. We have 2 oxygen, we have 2 oxygen. Okay, we have 2 oxygen. Let's go to hydrogen. 4 hydrogen, we have 2 hydrogen and 2 hydrogen, which makes 4, meaning that this equation is balanced as well. Now the last one, okay, the last one here, we have what? This is calcium oxide. Calcium oxide. You know that calcium is in group 2. Okay, calcium is in group 2, and oxygen, this is a combination of calcium and oxygen. So calcium is in group 2 and oxygen is in group 2, meaning that this has 2 and this has 2, meaning that they are going to cancel their valence numbers, meaning that we are going to have calcium oxide. So this is what you should be doing. You should just be solving it from your head. That is what we are supposed to do. So this is calcium oxide, then there's plus here, so this is in aqueous state. Okay, then plus, what do we have here? We have hydrochloric acid. So you need to know how to write hydrochloric acid, which is just like this, hydrochloric acid, like that. And an acid is supposed to be in aqueous state. This is actually a strong acid, so it will give us what? It is giving us here, it is calcium oxide. Okay, it's giving us calcium oxide. So this is actually supposed to be calcium chloride. Okay, this is calcium chloride. Calcium chloride. Calcium chloride. Okay, calcium chloride. So it is going to give us calcium chloride. Calcium chloride, calcium is in group 2 and chlorine is in group 7, which has a valence of 1. So mean that calcium chloride will be calcium chloride, like that. Okay, then plus H2O. This is the water here. So now how do we balance this? How do we balance this? So now we are going to check calcium 1. We have calcium 1. Okay, how about oxygen? Oxygen we have 1. This side oxygen we have 1. Here we have hydrogen 1. Here we have hydrogen 2. So what do? We introduce, or we put a 2 there. Okay, so mean that we have 2 hydrogens, 2 hydrogens. So the chlorine has been affected, so 2 chlorine. How about chlorine? This side we have 2 chlorine, so meaning that the equation is balanced. So that is how you can balance equations like that. Make sure that you include state symbols. They are part of the marks. Okay, like that. Include state symbols. All right, so that is what we are looking at today, and thank you for watching. I've been your tutor, Patrick Divine.